Let's start a new section. We're going to do basically a test called the limit comparison test. It's quite a long-winded test, as you can see here. I'll keep this here. I suggest that if you don't want to write that, which I can understand, you can wait until the video comes online, and then you can go looking at it in your own time. So rather than wait 5 minutes for you to copy it, I'm just going to keep it here and kind of show you what's going on as I talk through it. There are essentially two versions of the limit comparison test. There's the version that tests, do you converge? And there's a version that tests, do you diverge? And it says, suppose you've got a series, sigma an, and you have another series that you already know is convergent. The chances are you know that this series is convergent because it's a P series of some kind, or maybe occasionally a geometric series, but typically a P series. Now, if you take an, this piece, and you divide it by bn, and you find the limit as n tends to infinity, if this ratio is L, where L is any number you like, including 0, as long as it's not equal to infinity, then you can now prove that this will also converge. So you're comparing your guy to a convergent series. And if your guy behaves like a convergent series, then you converge. And that's called the limit, because there's a limit in it. Comparison, you're comparing two things test. Now, the alternate version of the limit comparison test is, suppose you've got your series and you're going to compare it to a divergent series. So you know it's divergent because it's a P series, right? What you do is you do the same limit of the ratio, and if you get L, where L is any number as long as it's not 0. So even infinity is okay, but it can't be 0. So it's almost the same situation, an over bn, and it's equal to something called L. As long as L isn't 0, then you can say that this guy diverges. So what the comparison test essentially, or the limit comparison test does is, it takes your series and it compares it to some known series, right? A series that you already know converges or diverges. Now, this process basically boils down into 3 steps. The first step is you find the comparison series, right? The guy that you're going to compare yours to. Second step is you find the limit of this ratio. And then you have a conclusion. So let's give you an example of how that might work. Here is a series. I would like to know, does it converge or does it diverge? That's all we're going to ask you for. And we're not going to ask you what does it add up to if it converges or not. So you're only going to have a dot that says converge or a dot that says diverge. And our job is to find which. So let's look at step 1. Find the comparison series. So what you do is you take this guy, who's basically your an, right? And you do the little surgery thing. Now, would you look at this guy, and if you want to look at what does it behave like, the top power, that's the guy that only matters. That's the guy that matters. And on the bottom, that's the only guy that matters. So do you see that you take the largest power of n in the top and the bottom? And that simplifies down to 1 over n. And this fella is my comparison series. So let me have a look at this fella and write him down. What do you know about this series? Does it converge or diverge? Because we did that yesterday, didn't we? Isn't this a P series? It's also the harmonic series. So does it converge or does it diverge?
It would converge because the power is equal to 1.
Ah, well, remember what happens when it's equal to
Less
1?
than equal, yeah, less than equal 1.
Yeah. So there are two versions. If the P is greater than 1, it converges. But if it's less than or equal to 1, as it is here, it diverges, right? So what do I know about that? That diverges. So step 1 is find your comparison series. I found it. It's 1 over n. Step 2. We're going to find the limit as n tends to infinity of this ratio. Now it's going to be really, it's going to be really ugly looking, because almost always these an and the bn are fractions, but here goes. It's an n cubed plus 4 over an n to the 4 plus 3n, that's the top guy, and the bottom guy is 1 over n. Okay, I want to find out what this ugly limit is. I'm not going to start doing anything clever yet until I've made it look pretty. Is there a better way of writing fraction over fraction that we can handle?
Multiplied by the reciprocal on the bottom.
Okay, so it's going to be n cubed plus 4 over n to the 4 plus 3n times n over 1. That in turn becomes the limit as n tends to infinity of n to the 4 plus 4n over n to the 4 plus 3n. Right, that's the guy we're going to find the limit of. There are typically two ways to do this particular situation. Couldn't we just use L'Hopital until we get an answer? Because sometimes you have to do L'Hopital 2 or 3 times before you get an answer. Couldn't I also do the trick of dividing the top and bottom by n to the 4? Remember that technique? Divide top and bottom, in this case by n to the 4. So n to the 4, n to the 4. This fella now becomes the limit as n tends to infinity of 1 plus 4 over n cubed, 1 plus 3 over n cubed. I can then do brute force, which basically gives me 1. So step 2 is find out what that guy is. Now it's conclusion time. According to the comparison test, if you are using a divergent series, which we are, and the limit is a number, as long as that number is not 0, which it is, then conclusion is that the original series diverges. So 1, 2, 3. 1, find the comparison series. Step 2, find the limit of the ratio. Hopefully you'll get a number out of it. If you do get a number out of it, then your series behaves the same as the comparison series. So your series in this case will diverge. Are we good? Right. Try another one. That one was a diverger. This one I'm going to do is a converge, just to show you can get converging as well. Ooh. No, sorry. That's a bad choice. Better choice. I like that one better. Okay, so step 1. We have to figure out who he behaves like. I think the bottom's the easy one, right? Now, a lot of the time, the top's just going to be n cubed plus 4n plus 7, right? It's going to be a polynomial. But I decided this time to just throw in a red herring and something that's a little bit messier. Now, e to the 1 over n has to be simplified. And so you have to think to yourself, what does e to the 1 over n behave like when n is really, really, really big? And the answer to that is 1. Now let's see if I can argue that. Wouldn't e to the 1 millionth be almost the same as e to the 0? It'd be 1, roughly. Does that make sense? The reason I took out the sine one is the sine one would have sort of worked. In the worst case scenario, isn't sine never going to be any worse than 1? So I would have probably replaced that one with 1. But I like this one better, so I kept that. So here is our comparison guy. That's Bn. Now, what do we know about our comparison guy? What do you know about this fella? Well, he's a p-series, right? He's a p-series with p equals 2. Does he converge or diverge?
Converge.
Converges. As long as the number is bigger than 1, it will converge. So step 2 now. Let's do the limit as n tends to infinity of the ratio. And that's going to be this guy over this guy. So it's going to be e to the 1 over n squared plus 3 times an n squared over 1. And now we need to do, or what we literally need to do here is figure out what this answer is, right? Is it 0? Is it 2? Hope it isn't, but it could be infinity as well, I guess. I wouldn't do L'Hopital on that, not in a million years. The bottom works really fine. Would you agree the top gets really weird and really ugly? Because you have to differentiate what's that, n squared, e to the 1 over n, not nice. I'm not saying you couldn't do it, but I wouldn't. I'm just going to do a simple version. So it's going to be the limit as n tends to infinity of e to the 1 over n, because that's what kills that off, and that guy. And now I can do brute force. Okay, 1 to the power of infinity. Right, 1 over infinity, I should say. 1 over infinity.
0.
0. So this becomes e to the 0 over 1. And wait a minute, isn't e to the 0 1? Isn't the answer 1? Agreed? Now, conclusion. Suppose you have a convergent series, which we have, this guy. Suppose that the limit is a number that's not infinite. Yep, we got one. Conclusion, our guy also converges. Now, for all this hard work, you come up with one answer. The questions just have 2 little circles, most of them. If not all of them, actually. And you pick that. I'm reminding you again, please do not just pick one at random. And if it says it's no, pick the other one, and that's you got the answer, correct? I mean, I probably wouldn't know if you did that, but I will know when I do a question in the test and you can't show me working. You can't prove it. So you got to be able to prove these things. Mathematicians, imagine an engineer just decided to guess on the answers to something. Yeah, it'll work. Let's just do it. Isn't that how bridges fall down? Right. You got to be able to prove what you're saying. You got to be able to say this is correct and here is my proof. Any questions so far before I do some more examples of these? You comfortable about picking a comparison, doing the limit of the ratio, conclusion? Okay, let's focus only on step one for a little while. This guy is like question 5. So I'm not going to do the whole question. I'm just going to do part of it. Okay. Let's figure out who he would be. What would you write down as the single term on the top in this question?
N.
Agreed. Think about this one for a few moments. What would you do for the bottom term?
N to the 5th.
Yeah. So won't this one behave like 1 over n to the 4? Isn't that a convergent series? Isn't that a P series that converges? So the next 5 minutes is all about just going through the process to prove it. But I'm pretty sure that's what you would end up with. How about this one, which is kind of like question 6 then? Okay, would you agree that the top line behaves like 2n or n, whichever you want? I'm picking 2n, but n will work. A little bit trickier. What will the bottom behave like?
N to the 6.
Which means that this guy is a 2 over n to the 5. Isn't this also convergent?
Would you have to write down the 2?
No, you could do it without the 2. The conclusion at the end is still going to be convergent, so it doesn't matter. Do you know if you keep the 2 in, it makes no difference. If you keep the 2 in, the final limit of the ratio is 1. If you take the 2 out, the final ratio is 2, but both are the same conclusion, right? It's just a number, so it's fine. This one is question 7. Let's forget about this guy for a minute. 1 plus 1 over n to the power of 4. What's that guy going to behave like?
1 over n to the 4th?
Well done. Yes, that's not obvious for some of you. Now, e to the negative n looks ridiculous, but basically when n is very big, isn't e to the minus infinity pretty much non-existent? It's just going to disappear. So you might as well call it 1. So this guy behaves like that.
Professor?
Yes.
Could we also interpret it like as 1 plus 1 over n to the 4th over e to the n? You
could, and you'd get the exact same answer. So it would work both ways. The reason I'm using that is, don't I know he's a P series and he converges? If I use that, I can't actually say for certain that that is a convergent series. So technically that was correct, but this is the one you really need to use. Your comparison series has to behave like the original, for sure, both of those do. But the second part is, doesn't it have to be typically a P series that I recognize? Something I could tell you if it converges or not. And if you stick an E to the N in the bottom, it's not really a P series anymore, isn't it? It's a something else series, but it's not a P series. Why can I
was
do
thinking,
that?
Like,
Keep going.
it was actually I had like 1 over into the 4th, and all that was over into E over e to the n's power.
Yeah, yeah. If you play about with it algebraically, it ends up being the same guy that I just did there. But I'm not. Yeah. So mathematically, we did end up with this. Why can I do that?
So as n approaches infinity, the maximum bound of sine would be 1.
Right. So the worst it could be, right? The most damage it could do would be 1. Let's keep going. I don't think you got one like that, which is fine. What about e to the 1 over, well, I'll make it a number. E to the 4 over n over n. Who does he behave like? Well, I'll take the bottom. That's easy. What do you think you're going to do with this 1 over n?
1.
Yeah. E to the negative n over n. Also 1. So keep going. Oh. A lot of my questions have sigmas at the front, but I'm getting lazy now not writing them. Okay. Back to a pretty standard one. Would you agree the top is n? What we're going to use the bottom?
N to the 3.
Yeah. You can have the 3 or not if you choose. Let's not have it then. Isn't that going to be a converger? Have you noticed that almost every one of them turns into a P series of some kind? Agreed? Right. You won't get one as hard as this, but I'm going to put it in anyway. God in Himmel, imagine trying to do that. Okay. What single power of n will the top behave pretty much like for large n?
N to the 7th.
Well, it's my funny decimal. It says 1.7, but I know what you mean. What would the bottom be?
1.5.
Whoa. Converge or diverge?
Diverge.
Yeah. Normally you get at least a 1 over. That's still a diverge, right? Because it's less than 1. But this one is so bad, it's even worse than this guy, right? It's even bigger than this guy. You could say, if this one diverges, this one is heck, it diverges, right? It really does diverge even quicker. Right, continuing. This is a version of 11.
So is n to the power of 0.2, is that also a P series or no?
Yeah. Yeah. N to any number at all, or 1 over n to any number. This one here is a negative, by the way, if you converted it to that. And this one would be a P series, definitely less than 1, that's why it converges. Oh, here's one, after saying that. Now, there's not a lot you could do to that guy, except to write down n to the power of 2.3. Inverse tan of n. For really, really big values of n, what's the inverse tan of that? Pretty similar to
Pi over 2.
I ever do. The pi over 2 really doesn't matter, because isn't this a p series where p is 2.3? The fact that there's 4 in the top or 1 in the top doesn't change a p series. Because it is 2.3, and that is a number that's bigger than 1, what can we say about this particular p series? Converge or diverge?
Converge.
Converges. To me, the hardest part is going to be to get the right comparison guy. Once you've got that, you actually know what your answer is. Step 2 and step 3 is to verify that you didn't screw up and choose a bad comparison, like you did some equivalence that wasn't quite right. Okay. But normally by the time you've done this, you already know if it's going to converge or not.
So
How about this
is there
fella?
any case?
Say again? Sam?
Is there any case in which we'd get a converge, but it actually diverges with us doing the
No.
right math?
If you do the right comparison, it will match exactly. If this is a convergent, so will the original. If you do the correct surgery, it is possible that you could screw this up, right? And you choose something that wasn't equivalent, but hopefully you won't do that. But I guess it's possible to screw anything up. How about this fella? Multiples don't matter. If you want to put the 6 in, you can. But the most important thing is that that's a half. And on the bottom, isn't the most important thing that that is an n? And then you simplify. And I'm going to call the half 0.5, but you can keep it as a half if you want. Isn't this a p series with p equals 0.5? And 0.5 is less than 1. So what does that tell me is going to happen here? Converge or diverge?
Diverge.
Diverges. Are we getting a flow for this algebra of taking something and comparing it, right? I call it surgery, right? You cut all the bits off and just leave behind the main piece. And that allows us, almost always, is going to be a p series. Technically, you could do a geometric series and do a comparison. I'm trying to see if there is one. I don't think there is. Oh, spoke too soon. Let's do a version of 14. Who do you think belongs on the top? And it should only be one thing, and it should have an n in it somewhere. So what do you think the most important part of the numerator here is?
2 to the n.
And the same argument, would you agree that 6 to the n is the most important part of the bottom? Now, this is going to be a geometric series. You might have to think about it a little bit harder. There. Can you see that it's a 1/3 to the power of n? Agreed? 1/3 to the power of n. Now, the common ratio here is 1/3. And for a geometric series, if the common ratio is less than 1, does it converge or does it diverge? geometric series if the common ratio is less than 1?
Diverge? No, converge.
Yeah. Now, do you notice that's kind of back to front for a p-series? If the ratio is less than 1 in a geometric, it converges. If the p-value is less than 1 in a p-series, it diverges. You notice that it looks very similar, but the conclusion you make is totally opposite of each other. I can't do anything about that. That's just what the truth is. Right? Let's do that guy. Step 1, we've got our guy, right? Step 2, we're going to do the limit as n tends to infinity of an divided by bn. And can I suggest to you that when you do these questions, that you don't use that guy. The reason I did that guy is just so I could figure out who R is. Well, you leave the thing in this format. It's just going to make the algebra a lot easier to do. Now, we've seen this trick before. Don't you take the top fella and you do a reciprocal thing, right? Let's see what that looks like. Geometric series tend to be uglier. So it's 3 times 6 to the n plus 2 to the n times 6 to the n. And then it's 5 times 2 to the n plus 6 to the n times 2 to the n. Right, I don't think we've done a limit quite like this one. So it's going to be 3 times 6 to the n. Won't 2 to the n times 6 to the n, can't you combine that into a single 12 to the n? Great. And on the bottom, you've got 5 lots of 2 to the n plus 12 to the n. And the next stage is not that nice, but it is doable. We have to figure out what the limit of this fraction is as n tends to infinity. If you're thinking, there are only 2 guys, L'Hopital or divide top and bottom. Can you trust me that L'Hopital goes nowhere? It just gets uglier and uglier and you never come out with anything. So I'm going to do the divide top and bottom trick. Okay, and I'm going to divide the top and bottom by 12 to the n. Let's see what this turns into. If you take 6 to the n and you divide it by 12 to the n, are you comfortable about where the half to the n comes from, or do you want to see the working? 6 to the n divided by 12 to the n, 6 twelfths to the n, a half to the n. Right, that's what I did. Plus 1. If you take this guy and you divide it by 12 to the n, you get 5 lots of 1/6 to the n plus 1. 2 to the n divided by 12 to the n, 2 twelfths to the n, 1/6 to the n. Okay, now I can do brute force. It's not as weird as it looks. What will a half to the power of infinity get you? Actually, any number less than 1 to the power of infinity. What will that become?
0.
Yeah. You know, like a half to the power of 100, a half to the power of 1,000,000, disappears to 0. So you get 0 plus 1, 0 plus 1. The limit is 1. And bingo, you have got a converging series. And that's it. You don't try and find out what it adds up to. You just find out if it converges or not. And this particular one does converge. Okay. I'm looking at some of the harder ones now. So this is like 16. Okay, let's do this one a little bit more formally. Is this guy going to end up being a P-series or a geometric series? Just by looking at it. P-series or geometric series. That's the only two guys in town.
P-series?
Agreed. I think there's only one. I may be wrong. Maybe there's a second one and I've missed it. But geometric series questions are quite rare. But if there is a geometric series, isn't it full of 5 to the power of n and 2 to the power of n and a half to the power of n, right? It's full of those kind of things. Right, time to do surgery. I'm doing the bottom one because it's easy. Tell you what, can I forget the 4 just to make my life easier? What's the top going to be?
N to the half.
Well done. If you'd said square root of n, I would have written it down, then I would have turned it into n to the half, but knowing it's n to the half right away is much better. Doesn't that simplify down as n to the 3/2? Now that's a P series, and the P is 3/2, and 3/2 is bigger than 1. So you have to remember the P series. If it is bigger than 1, converge or diverge, and it's a P series we're talking about.
Converges.
So actually, at this point in time, don't we know the answer is going to be it converges? But don't we do the other 2 steps just to prove it? So step 2 coming up now. We're going to find the limit as n tends to infinity of the original, the en, as we call it, all over that guy. And here's a little piece of algebra coming up. I need to combine this square root with this guy. But the way that they are written doesn't make it obvious how that's going to happen. So I'm going to rewrite it as the square root of n cubed, right? That's what that is, right? Now, if I write it like that, do you see that you now have 2 square roots? And can't you multiply them together now? And this single square root is an n to the 4 plus 2n cubed. That's a good start. Again, we have to figure out what the heck we're going to do to find this limit. And we just need to make sure it's a number and it's not 0 or infinite, right? As long as it's a number 1, 2, 4, quarter. Right. L'Hopital, not a chance in Hades. So it must be divide top and bottom. You must divide top and bottom by the same thing, right? You're not allowed to put something like n cubed in the top and n squared in the bottom. That doesn't work if you do that. On the bottom, I'm going to use n squared. That means I have to use n squared on the top. Unfortunately, there's a little hiccup there. I'm not going to use n squared directly. I'm going to use the square root of n to the 4, which is n squared, isn't it? just a different version of n squared. Why did I convert it into this? Only for the top.
To cancel the other square root.
Yeah, so I can now divide these guys by him. So that gets me the square root of 1 plus 2 over n. And the bottom gets me 4 plus 1 over n plus 1 over n squared. Now, can't I now do brute force? Square root of 1 plus 2 over infinity, which is basically just a square root of 1. And on the bottom, 4 plus some zeros. And the answer is 1/4. As long as it's a number and it's not 0 and infinity, that's good news. Because conclusion is that the original behaves like the comparison one. And the comparison one converges. So does that one.
Question. So when you
Yes.
divided the square root on top by the square root of n to the 4th power, wouldn't
Mhm.
the square roots cancel?
No, the algebraically, they're still there.
Okay.
Right. If I do numbers, if I said to you square root of 8 divided by square root of 2, just for argument's sake, then I'm saying you can do this. The square root is still there, and you get that. If the square root's cancelled, do you see you do not get the same answer? Algebraically, it doesn't work.
Okay.
So the square roots are not cancelling each other. The square roots are there so that you can divide like with like, right? So that whatever is the first thing is being divided by something of a similar look as the other thing. That's why we did it. Covered a lot today. Is there any more questions before I do my kind of tidy up for what's happening? Are we good? Right. Your test is coming up. It is not on Monday. I've now changed that, so it does have the right answer. Why is it not on Monday?
Holiday?
It's a holiday.
Yes, holiday. So it'll be on Tuesday. Okay? So when I see you on Tuesday, you'll be doing your test. Will you all say hi if you haven't already done so? We've basically finished that section. So when I see you tomorrow, we'll be moving on to our next section. So it's called the alternating series test. Yet another test for convergence. Well, we'll wait till tomorrow to talk about it. And that is me for today. I'm going to hang about. If anyone has any other questions, just hang about and ask me. I shall see you tomorrow. Bye-bye.
Have a good one.
Thank you.
You too. Have a good one, guys.
Thank you.
I have a 3-second question.
Oh, I like 3-second questions. Go for it.
So on the second to last problem,
I just threw it away.
we had
What
determined,
does it say?
basically we
What
had
does it say?
determined that it was convergent. It was the geometric series.
Right.
And we got a 1 for the final answer. And I was wondering, because when I'm looking at my notes, it says
Mhm.
that when r is greater than 1, it diverges, but when r is
Correct.
less than 1, it converges.
Yes.
I was wondering if that's less than or equal to 1 instead.
For diverging, it has to be less, well, rewind. For converging a geometric series, the R value must be less than 1. And if it's greater than or equal to 1, it will be a diverging series. If that's your question.
So the Okay,
The
so
one that
when
we
that's
the one that we got, wasn't it that fella? Let me show you. If I recollect, wasn't it 1/12 to the n? And so the R value was 1/12. Was that the guy? I guess I should look at my notes.
it was 1/3
Should
to
throw them
the
away
n.
so quickly. Oh, okay. Well, 1/3 is still less than 1, isn't it?
Yeah.
So that's why it converges.
So that makes sense. But then when we did the step 2, we got 1.
Okay. Yeah, but step 2 is finding the limit of the ratio. And that's a different process. That can be anything. That can be 5, 1/2, 2004. It just needs to be a number. The only restriction on it is that the number isn't allowed to be 0 or infinity. I guess infinity is not even a number. At least in each case, there's an exception. Don't be infinite in this case and don't be 0 in this case.
Okay, that makes sense.
And 4 is okay and 1/2 is okay. They both come to the same conclusion.
Okay, cool.
So step 2 doesn't care what the number is as long as it's a number and it ain't 0 and it ain't infinitely big.
Cool. That was the end of my question. Thank you.
Okay. Douglas, you got one?
Oh no, I was just listening.
Okay. Ivan, you got a question?
Yeah, I just had a quick question about the test.
Sure.
Is it, I don't know how
Yes.
you roll your tests. Is it open note or is it all closed, or how are you going to do it?
You are allowed, you haven't had me before, so I'll tell you what it is. The others are a little bit more used to me. Anything that's physically written down, you can use. You can use PDFs and textbook. You can use pretty much anything of that type. All the homework will be locked out, so you won't be able to go back in and find the same kind of question and just use that as your guide. So that
Unless
will be
I
missing.
wrote it down previously, right?
Well, that's a different kettle of fish. If you've written it down, you've written it down, and that's okay because it's now physical notes.
Okay.
You got to be careful. If you write too many notes down, you'll run out of time because you'll be spending 20 minutes trying to find the same question, and that won't help. So you got to hopefully have most of it in your head. You're not allowed to do any kind of human or human software interaction. So you're not allowed to go to a help page and type in somebody in Canvas, like in tutoring, I need to know the answer to ABC. That's cheating. You're not allowed to, phone a friend, whatever. That's anything interaction. So if it's physically written down as notes or a PDF, you're good to go. You can use it.
Okay, and then it's just the length of the class period, right?
Yes. So you won't get too many questions because of that. But once it's finished, you have 30 minutes to get the pictures taken of all your working and uploaded into Canvas. When you go to Canvas, there'll be a new link that's not there until it needs to be, which says upload your work in here. And I'll have a video showing you how to do that. I think, Sam, since you're here, Douglas, you're here. I think after you've done it the first time, is it pretty obvious how you go about this process?
Yeah, it becomes pretty clear.
Yeah.
But yeah, so
It's pretty
you'll get used to it. The first time it might be a little bit clunky, but I'm going to be around at least for part of that time, so you can always say, "Hey, I'm not sure how to do this" or whatever. Hopefully, you won't.
Okay. Okay.
Any other questions?
I have a question on the homework.
Sure.
So
what one?
It's on the integral test 11.3, and it's question 8.
Okay, I don't have that handy. Do you want to tell me what the guy is, and I'll do it?
Yeah, so it's sigma with k equals 1 to infinity, and the actual equation is ke to the negative 7k.
That guy there?
Yes.
Okay, so the equivalent integral is going to be this guy. Agreed?
Yep.
And that is going to be converted into the pretty standard that guy. So I'm assuming that isn't your issue, right? It's
No.
how
yeah,
to
it's
integrate
perfect.
this guy.
Yeah.
Right. What technique am I going to use? That might be your problem.
When I did it, I thought integration by parts is.
You're correct. That is the
Okay.
right method.
Yeah. Then I must have just done it
So
wrong.
let's do integration by parts then. So I'll call this F and I'll call this G. And so what we're going to do is F big G take away the integral of F dashed big G, right? Dx. And technically there's that thing going on at the side.
Mhm.
So it's going to be the limit as t tends to infinity, right? Leave that again, leave that guy alone, you get x. If you integrate e to the negative 7x, you will get e to the negative 7x. What else will you get when you
Would it
integrate
be
e?
over or like a negative 1/7? Or like over
Yeah.
negative 7?
So I'll just stick it over here.
Okay.
Yep. Take away f dash gets you 1, and that integral that you just mentioned, repeat it again.
Okay.
So maybe you're still good, right?
Mm-hmm.
You got something like that? So it's negative 1/7 x, this fella, plus 1/7 this guy. And the reason it's a plus, they two cancel. Those negatives cancel.
Okay.
And then I'm going to do just a normal integral this time. And you will get e to the negative 7x times another negative of 7, so that becomes negative 149. And we'll evaluate that at x equals 1 to x equals t. And we now, did you get to there?
I think I messed up on the like the integral part of the second part of the equation. So this.
Okay, so right, this is going to take us to the next stage then. So I'm going to do plug in t. So it's it's negative 1/7 t to that fella. Take away 1/49 e to that fella. And then subtract what you get when you plug in 1. You get a 1, you get a 1, so that's negative 1/7 e to negative 7. Take away that fella, e to negative 7. I can brute force this fella, and if I do, you just get e to the negative infinity.
Okay.
These two guys are a real pain in the butt, but if you take these negatives and join it to that, you get a plus. And if you combine this to that, you get eventually, I believe, 849's e to negative 7. You can double check that, but I think that's correct. The problem is this fella here. I'm going to have to figure out what the limit as t tends to infinity of a really weird looking fraction. And although it doesn't look much like a fraction, it will in a few moments. I need to figure out what that guy is. And I'm going to call this negative t over 7e to the 7t. Right. Yeah, I've gave the negative to the top. I've left the t on the top. I brought the 7 downstairs, and I brought the negative power. Now, because I have written it as a fraction, it's now a L'Hopital. And the top gets me negative 1, and the bottom eventually gets me that fella. And now I can brute force it, and it gets you 0. And by the way, so does that guy get you 0? And so what do we have? We have
then it just
a number.
converges
So
to
it
that number.
converges.
Okay.
Well, it just converges. We don't say it converges to, the sum does not equal that.
Oh,
but
yeah,
it can, the limit converges to that number. But all you're being asked in this question is typically converge or diverge.
Yeah.
In which case, you would fill in the converge.
All right. Well, that cleared it up a ton for me. So thank you very much for that.
You are welcome. Do you mind if I keep this on the video so others can look?
Oh yeah, for sure.
Right.
Is,
Are we
um,
good with yours, Douglas? Sorry.
The two tests that for us to find the sum is the P series and the geometric series test to find the sum.
The ones that
that?
allow you to find the sum, right? The one that allows you to get a total is only the geometric series. The geometric series is the only series in which you can actually tell what the sum is going to be equal to when it converges. All the
Okay, and
other
then so
series, all the other tests, all they tell you is converge or diverge. Now, for instance, the one we've just done here, the integral test, that number isn't what this adds up to. That number just tells me that this converges, and that's all. I
Right.
can tell you a little bit. I'm 99.9% sure that this adds up to something different from that, probably something a little bit bigger than that. But that ain't any help, because how little is little.
Yeah.
So all you can say for sure is it converges, and that's all you need to know. Does it converge or not? So almost every test that we've done now, and the ones that are going to happen in the future that we haven't done, you're going to find out that you can tell if it converges or diverges, but very, very rarely do you ever know what it converges to.
Okay, gotcha.
If you want to know what it converges to, plug that guy into a computer and ask it to add the first 2 million terms. That'll be good enough. That'll be a good estimate. Any other
Thank you.
questions? Are we good? Sam, have you got another question, or pardon me, are we good?
I do not. Good.
And we are out of here. Have a nice day, guys. I shall see you. I'll see you tomorrow.
This one.
All right. Have a good day.
You too.